Okay, so I'm going to talk about the foundational infrastructure work that I performed. It's related to the GNON infrastructure with regards to registries, semantic management, brokering, and kind of the glue that keeps this all glued together, which is the federation mechanisms. Okay, so I'll go through some GNON requirements and realities, and then I'll talk about the registries, and then the semantic management, and then the brokering, and then the federation. So from the Eye on Earth Summit website, there's a mission statement for GNON, and I won't read it all to you, but the most important part from our perspective on the foundational infrastructure team, and certainly from my perspective, is the part in bold, which basically says that GNON needs to interlink different tiers of government, societal groups, communities of practice, and geographies. And so this is a pretty bold mission, and it's really important that we can deliver on this, because this is what would basically deliver the benefits of what GNON promises to all those participants in GNON. So some of the GNON requirements, and these we had agreed to long ago. Standards-based mechanisms need to be used, both for syntactic and semantic interoperability. We should have a federated methodology rather than a centralized approach, which is what some of the other global initiatives try to do. We should use web-based services and APIs as much as possible. We should have modular component development, and we should aim for a plug-and-play sort of architecture that allows limited customization. We should have support for capacity building and implementation that provides a low barrier of entry to GNON, and we are going to achieve this using a reusable reference implementations of the core GNON components that I'll be discussing, and a minimum subset of functionality that are supported by open specifications that are implemented and made available at the interfaces of each GNON component. And that last bullet will become a little bit more clear later on in my talk. So some of the realities, or a couple of the realities of GNON, are the first two bullets. First of all, of all the participants that would play a role in GNON, and by participant I mean those agencies or research groups or countries or whoever that data providers that want to participate in the GNON, in the GNON, they may have their own tools. They may have their own registries, they may have their own brokers, and so we don't want to force them to change what they're doing and to use other things that we say we are developing. And also there will be many participants that may not have all of the core components. Maybe they have some of them. Maybe they don't have any of the tools that are required. So therefore, what we need to do is we need to focus on what we call reference implementations and a federated architecture. So the reference implementations are implementations that have yet to be funded, but presumably would be funded to be developed. These reference implementations would be open source and would be downloadable, deployable, and usable by whoever wanted to use them if they needed them. You wouldn't have to download and use an entire set of tools. You could take the one you don't have or the ones you need, and they would be customizable to some extent. The federated architecture is of primary importance because that is what allows the non-centralized nature of GNON. We did not want a large, massive centralized infrastructure because that is hard to scale and doesn't really easily allow membership in GNON to be fluid and dynamic. So, so with that said, let me talk about registries. This is the first set of tools and core components that I'll talk about. So There are different types of registries. Everyone, I think, understands what a registry is. The ones that we've focused on initially in GNON are standards registry, a semantics registry, a best practices registry, a requirements registry. By requirements, I mean, well, I'll go into a little bit more detail about that later, but sort of user requirements in terms of data, knowledge, tools, processes, things like that. And an asset registry. An asset registry is a registry that contains information about the different GNON assets that have been deployed and that are being used throughout the whole global network of networks. Now, I don't want the use of the words here to confuse anybody, so I am not suggesting that there's one standards registry. These are the types of registries. Every community could potentially have their own standards registry and their own semantics registry. So there are no requirements that we have in the GNON architecture that say that there's some core central registries. So everything be realized individually by communities or other types of groups, and we federate it. So the reference implementations for these registries would be based on customization of known instantiations. So we don't want to reinvent the wheel. So we'll take things that we currently have access to that provide decent solutions and modify them as necessary. So there's a standards registry, for instance, at GEOS, and a best practices registry there. EarthCube is developing a standards registry and a requirements registry. So when we can reuse what already exists, we will. Standards registries in particular, they can include community standards as well as well-known, global or even regional standards. Sometimes we refer to community standards because they're not, nationally or internationally adopted by a standards development organization. Sometimes we refer to these things as special interoperability arrangements. I didn't want to confuse the words here. So community standards are allowed. The minimum information that would be required for making entries into a standards registry from the GNON perspective would be a title for the standard, a common name, version description, the standards taxonomy category, and by that I mean there are many Earth observation, for instance, Earth observation categories that standards fall into. For instance, formatting standards, data access standards, streaming protocol standards, metadata standards, etc. Of the standard, which is usually going to be the standards development organization that has taken on the responsibility of disseminating and maintaining that standard. Now, based on experience that we've had in GEOS, it gets confusing because standards are sometimes referred to by their title, sometimes they're referred to by a short name, like a nickname almost, and it's kind of hard to link these things up properly. And we looked into using URNs so that we could have unique identifiers for these standards, but it didn't work out. We did not have any success with that. Certain standards development organizations who had tried to implement URNs did not succeed. So that's still an open question. So that kind of an issue may still exist within GNON, but it's something certainly that we can look into going forward. With regards to semantics registries, the entries in these registries would include all the semantic assets that could be used in GNON. So this would include vocabularies, taxonomies, ontologies, and the like, thesauri, things like that. We would use well-known and community-based assets in order to develop the registries. Some of these things that exist would be like the bioportal, which has a semantic registry on the back end. Protege is a semantic tool, and things like that. links to assets, links to semantic assets can be used, as well as direct content. So what I mean by that is that just because we have a semantics registry, a reference implementation of one, or a community has stood up a semantics registry, we're not requiring that any given semantics registry must contain the content for every asset or resource that it needs to use. So we can use links, and these links would be navigated and utilized with the architecture that we have in place, and also with regards to the federation capabilities that would be in place. And the semantics registries, the reference implementation, would be based on an RDF triple store. Best practices registries, entries minimally include best practices, tutorials, guidance documents, things like that. It's not just limited to what's considered a quote-unquote best practice. Sometimes there are community, what I would call community best practices. They're not necessarily widely adhered to, but they are adhered to by the community. And since we are trying to address communities here in addition to other groups, that certainly deserves a place in the best practices registry. Again, well-known and community-based assets will be utilized. Like I said, can be used instead of just plopping, the entire document into the best practices with a registry all the time. So we can link to them. Requirements registries. So these entries can include community requirements, not just global requirements. Minimum information that would be required would be the name of the requirement, the description of the requirement, and the links to resources that satisfy the requirement. So an example of this might be, for instance, that there is a data requirement that a group may have, maybe to support decision making, and that requirement would be that they need data from a certain region, and certain geospatial, say, bounding box over a certain period of time, and maybe within a certain range of data values. And if that requirement can be found, then the link to that would go into the requirements registry under that requirement. So if somebody has a similar requirement, they now know exactly where to get it. And so, as I sort of just mentioned, these requirements can take into account data requirements, information, knowledge requirements, semantic requirements, and so on and so on. Okay, and then the last set of registries that are important are the asset registries. Again, this is for keeping track of what is out there that can be linked to and federated within the GNON architecture. And those entries would include, for the asset registries, would include at a minimum the name of the asset, the type of asset, whether it's a standards registry or a broker, etc. The link to that asset user interface, and a link to that asset's interoperability endpoint. And those endpoints could include discovery and access endpoints and also federation endpoints. And what I mean by federation endpoints will be clear a little bit later. Just as there is sort of a main root node for the DNS system of the Internet, we will have one central GNON asset registry that we must have, but it isn't necessarily the one that will always be used, but we have to have it. And it will be replicated across other asset registries that get stood up and that exist within communities or within other groups that are participants in GNON. But we have to have one central one that's always available. Okay, now the possible GNON registry interface looks like this. this is not exact. It's just sort of a mock-up. The colors, everything else related to this could be changed when it's actually implemented in the reference implementation. But the idea here is that there is one interface. So you don't go to a separate URL for each type of registry. You have a registry interface. And in that interface, you can then choose from the menu on the left whether you want to work with an asset registry or a standards registry, and so on. You can configure the interface. You can add registry types. So this is not stuck in time. If, a year from now, 2 years from now, there's a different type of registry that needs to be recognized and usable within GNON, we ought to be able to easily add it to this interface. Of course, documentation and help. And once you pick a registry, in this case the asset registry was chosen, the appropriate functions would be menu options along the top. So you could enter a new entry into the registry, search or edit, and those sorts of things. So again, this is just a mock-up and a proposed interface, uniform interface. So the purpose, as I mentioned, behind this is that there's a uniform and consistent way to interact with the registries. It exploits interoperability and federation mechanisms of GNON so that these registries can all be handled similarly, and they don't all have to be centrally located. They can be used with the reference implementation. This interface can be used with the reference implementations of the various registries. The ones that are reused by communities or other groups. These interfaces can be customized to some extent, and they must follow the GNON requirements and principles. And it can be extended through plug and play. So as I mentioned, if there's a new registry that becomes desirable, we can plug it into the interface. Okay, let me talk a little bit about semantic management. So the semantic functions that we focused on initially in our GNON foundational infrastructure work included a semantic registry, a semantic mapping function, a semantic mediation function, and a semantic reasoning function. Again, reference implementations of those things based upon limited customization of known instantiations would be used. Again, GEOS and EarthCube may play a role here, and other open source tools, as I mentioned a little bit earlier. Again, we're not going to reinvent the wheel. This is the uniform interface for semantic management. We call it the semantic management interface. It's similar to the registry interface, so that there's a common look and feel, so people using these tools, don't have to learn how to use different tools in different ways. So again, the different types of semantic functionality would be available along the left menu. It can be configured, and you'll notice that there's a button that says that you can add a semantic function. So if in the future, just like with the registries, if there's a new semantic function that we wish to support in GNON, and it is realizable through some kind of a tool or component that has been made to be GNON aware, then we can add that easily to the interface. And again, when you pick a semantic function on the left, the appropriate options for it show up along the top.
Steve?
Yeah.
See, this is Derek. If I could just ask a question, could you elaborate, please, on what you mean by a semantic function? I'm not sure. Perhaps you could give an example. Explain.
Well, so for semantic registry, the functionality is that we can enter and modify elements in the registry that point to semantic content, vocabularies, ontologies, those sorts of things. Semantic mapping is the function that takes place if you need, let's say you have two ontologies, and maybe a better example is two vocabularies. And those vocabularies are being used to be able to utilize data, information, and/or knowledge that's been found. But there are terms that aren't exactly the same, but maybe they mean the same thing. They refer to the same thing. So the mapping function is a way for somebody, typically this is done by a domain expert, to take the two terms from the two vocabularies and map them and say, well, you know, if I'm talking about sea surface temperature spelled out in one vocabulary, if I'm using another vocabulary to access information and it refers to it as just, you know, water temperature, I'm going to map those together so I know they're equivalent. So I get the same. I get the same meaning for both pieces of data that come with those different vocabulary terms. I understand that they mean the same thing. Semantic mediation is a way to functionally mediate, sort of like be a broker to some extent, not in the sense of a data broker, but in the sense of a semantic broker. So it's similar to the mapping is the function that takes place in terms of actually creating the maps. Those maps would go into a registry. The mediation is the function that actually uses those maps to navigate between equivalent terms or narrower terms or broader terms, those sorts of things. And semantic reasoning is a functionality that actually it's sort of like a reasoning engine. It allows semantic information to be to be traversed essentially in order to extract information or knowledge from a set of semantic assets based on the logical and relational relationships between the different semantic assets that are in the registry or the mappings. So right now, those are the four main areas of semantic functionality that we could potentially focus on initially. Does that answer the question?
Yes, it did. Thank you. That absolutely. Thank you very much.
Okay. Okay, so again, this semantic management interface provides a uniform and consistent way to interact with GNON semantic functions. It exploits the interoperability and federation mechanisms of GNON. It can be used via the reference implementations, just like the registries. And again, just like the registries, it can be extended through plug-and-play architecture. Let me talk a little bit about brokering. Now, many of us have heard quite a bit about brokering, so I'm not going to spend a huge amount of time on what it is. I just want to recall some of the benefits of brokering. So it lowers the barrier for participation in distributed systems. It accelerates the interconnection of disparate systems and especially multidisciplinary interoperability, which is probably one of its main benefits. It enhances multidisciplinary interoperability. There's no need to impose, if you're using brokering, there's no need to impose common specifications among the participants. So what that means is you have a data provider and a data user, for instance. If you're using a broker, then there's no requirement that the data user and the data provider have to speak the same language. I don't mean natural language, I mean data language. So they don't have to use the same standards. The point of the broker is that it mediates between the standards that are being used by the provider and the ones that are being requested by the user so that they can use the data that's been found. And brokering also enables sort of a more bottom-up evolution of an infrastructure. And that's because there are no requirements coming from top-down governance that says if you want to participate, you must modify your software or modify your processes to use these standards or these technologies. It's more like if a community wants to join GNON, for instance, using brokering, all they need to do is basically register their data assets and say, these are the standards I use. And if the broker understands that standard, they're immediately part of the GNON, they're immediately part of GNON. If the standards are not known by the broker, then there has to be some work done on the brokers, from the broker's point of view, to understand that standard and work with it. But it doesn't require very much, if any, effort from the actual data provider. So this is a diagram that I got from CNR. It kind of illustrates how the brokering mediates between heterogeneous types of assets. So the brokering services allow, this mediation to take place between data, models, knowledge bases, semantic assets like vocabularies or ontologies, and tools and workflows. A working definition, this is from our project with EarthCube, of a broker framework. First of all, the only important parts, because I've talked about this definition already basically, but the important parts are the things in bold. In other words, a broker can adapt to quote-unquote brokering different assets at runtime. It's not something you have to bring down, reconfigure, and then boot up again. Everything can happen in real time. So as a broker runs, if I wish to say, hey, I'm a new data provider and I have these data assets and I want them to be brokered, I can configure the broker to know about my endpoints, and boom, as long as everything is working properly, it'll broker my assets. So that's very, very important. And then, of course, the other bold part here, which is important, is that this takes place transparently. The broker doesn't require any actions on the provider or the user's perspective to make brokering happen. So the data can be shared, in a multidisciplinary, inter-community approach relatively transparently. The broker is the one that makes and receives requests and responses from the different endpoints, and once it's been configured, does not require any additional work from the provider or the users. So there are many different types of brokers, and different brokers may have different desirable functionalities. So Community A, for instance, might have a broker that provides certain functionalities, and the Community B might have a broker that provides different types of functionalities. All kinds of possibilities exist. It is not true that there's a broker and that one broker satisfies everybody's needs throughout the world at all times. That's not true. There are many who want to try to have it that way, but it's never going to be that way. And many communities may have their own brokers that satisfy their own individual community needs, and no two communities need to have the same types of brokers or the same functionalities. So the important point here is that from the GNON perspective, with regards to brokering, GNON is not a centralized infrastructure. The principles and the requirements that we have do not lend GNON to having some kind of core broker that serves all of GNON. That's not going to happen unless the requirements change. The way we're moving forward is that we have a federated infrastructure or architecture, and that means that we need to be able to work with all kinds of different brokers. So the current brokering approaches, so this is a picture of where you have multiple instances of the same broker, because they're the same color. So broker 1, 2, 3 up to broker n. These are all sort of scalable instances that have been instantiated, say in a cloud, which is what most people are using nowadays. They're the same broker. They offer the same benefits, they offer the same functionalities. And the only purpose of these multiple instances is to deal with scalability issues. But all the users basically just hit, say, the load balancing front end. They don't know which broker they're actually using, but to them it's just one broker, one central broker. Another aspect of a current approach is that, as I mentioned, communities might have their own brokers, okay? And so it may be one broker, it could be a cloud with multiple instances, but the communities, as you can see, are sort of detached or decoupled. There's no interlinking or interoperability or interconnecting between these communities. They deployed their broker, and the community uses it, and nobody else can. This is the situation that we in GNON would like to address and to provide mechanisms to interoperate with these communities. So, so we talk about broker interoperability. So suppose that you have, in this case, you have n brokers. These are all the same brokers, but but they interoperate. In other words, they're not necessarily deployed in the same cloud. They could be in different communities, but they're the same broker. So they have the same functionalities. They expect the same. They have the same endpoints essentially, except for the main domain, and they all work the same way. So they have known interoperability mechanisms, and there's a mutual understanding as to how they all work and how they all function. And so this is one way to sort of decouple the centralized idea, but it's still working with one broker, just multiple instances of it in different locations. Probably the situation that's more akin to what we're talking about in GNON is that you have different brokers, illustrated by the different colors. These are brokers that have different functionalities. They're not the same broker. They could be completely different brokers, developed by different, groups and organizations, and they have different functionalities, or they may have the same functionalities. They may overlap with certain common functionalities, but those functionalities behave differently. So this situation also could benefit from interoperability between the brokers. But in this situation, you have unknown interoperability mechanisms. This requires possibly new standards. You'll see a little bit later that this will be addressed by the federability mechanisms that we've worked on in the foundational infrastructure work. Something like this may require new coordination policies, and certainly some governance issues would need to be addressed.
Steve, can I just ask a question? Hello?
Okay, let me talk about the question.
Yeah, Steve.
Yeah.
This is Derek. So if I understand what you're saying there, the protocol, the interchange protocol between brokers.
Can you hear me?
Yes, I hear you. Can you hear me? No? Okay, I will.
Yes.
Okay. We'll forget the question. I think we'll carry on because
I can hear you, Derek.
Okay. My question was, perhaps you're going to come.
Can you hear me?
Yes, I hear you. My question is the protocol for the interbroker protocol. Are you saying that that you're going to be explaining subsequently a method for dealing with kind of brokering between brokers, if you will, brokering broker protocols? Is that what's necessary?
Yes. Yes, so I will talk a little bit about it at a high level. I won't go into gory detail, but yes, I'm going to address that momentarily. Can you hear me?
Yes, okay, thank you.
Okay. Okay, so let me talk about federation then. So GNON federation will be realized by a RESTful API. So this is just part of the architecture. Restfulness is not a standard. It's more of an architectural specification. GNON federation will be supported by semantic interoperability, and will need a small central register, as I mentioned, sort of like a root node for linkages to what I call GNON components that are part of the GNON federation. And so this little small central register is what I referred to much earlier as the GNON asset registry. Even though there's a central one, it doesn't mean that it's the only one that can be used, because I had mentioned that these asset registries could exist in many communities, but we need to have at least one that we know exists. And this is a very small thing. It's not a big thing and requires very little in terms of hardware and other types of deployment requirements to utilize. Within the GNON federation, two things have to be true. GNON components must be able to find and utilize each other so they can capitalize and benefit from the federation and interoperability mechanisms that are available. Okay, so that's part of the asset registry's role. You got a component needs to be able to find other components. And the GNON participants, those organizations, research groups, communities, should not be expected to understand and accommodate all the standards, whether they be syntactic or semantic, that could be used. So this is also sort of bringing into play the idea of brokering and also federation. So this is a canonical federation. When you talk about a federation, basic definition looks like this. There are a bunch of nodes that each, quote unquote, belong to the federation. And there's a federation bus, which, you know, could be logical, it doesn't have to be a physical bus, but they're all linked through the internet. But the main idea behind this canonical federation is that all of these nodes must adhere to all of the standards and protocols and requirements of the federation. If they don't, they can't properly and successfully participate in the federation. So the part in red below is the most important part, what I just mentioned. So those have to be adhered to. If they're not, the federation will not work properly for one or more nodes. For GNON, what I'm suggesting is that we still have the idea of a federation bus, although it's logical. Again, it's over the internet. But we don't require all GNON components that want to take part in the GNON Federation to all adhere to the same standards and protocols and the same requirements. They're sort of categorized by what type of GNON component they are. So for instance, I don't know if I actually mentioned it here, I guess not, but so for instance, the green circles, C1 and C2, those might be GNON components of the registry type, maybe standards registry type. And so they have to agree on how to communicate with each other, but they don't have to agree on any of the other components that would participate in the GNON Federation. So the GNON Federation would be based on different requirements, different standards and protocols based on the type of GNON component that's trying to reach out and communicate with similar components. And this idea can be extended to make it more broad, and allow maybe wider communication between components. But for right now, this seems to be what's really indicated right this second. I mean, for instance, there's no reason at this point to say that a standards registry needs to communicate with a broker. That doesn't make any sense to me at this point. So we have federation, but it's layered by category of GNON component. So the big question is, how do you join the GNON Federation? So let's suppose we had all these reference implementations actually implemented. They were all available to be used by communities or other participants to GNON. What does it mean to actually join the GNON Federation? Well, first of all, joining the GNON Federation means that it can be used, you know, at will by any network or network component that wishes to participate. We don't have, at least as far as I know at this point, from a governance point of view, there are no restrictions other than technical software restrictions that would keep somebody out of the GNON, And the loosely linked nature of the federation would ensure that it's easy to become a member of the GNON Federation, and it would also be easy to revoke yourself or delete yourself from the Federation. There's no simple, steps you have to go through, really. In terms of being GNON compatible, in terms of the Federation, so what does it mean for a software component to be GNON Federation compatible? So a software component is compatible if it adheres to the GNON Federation requirements, some of which I mentioned way in the beginning, and especially the interoperability requirements. So this is an example of one way of joining the Federation. So this is what I call a dependent Federation component. So you have a GNON component. That component consists of different software pieces. that make up that component. And the federation component for the GNON federation functionality actually becomes part of that component. In other words, whoever has implemented this has made it part of that component. So it's not external to the component's functionality, it's internal. And so in this case, the federation component can communicate with the, or interact with the other software pieces of this component through internal mechanisms. They could be function calls, internal function calls. But the federation component is what interacts through the internet with other GNON components of a similar type for this GNON component. So this is a dependent federation example. And then there's an independent federation component example. In this case, the federation component has actually been implemented external to the software that makes up the GNON component. And that means that it's deployed. It could be on the same server, or it could be on a different server. Typically, it would be a different server. It's logically part of this GNON component, but it is physically separated in terms of the interoperability or the invocation of functionality. So in this case, what happens is the federation component is this federation piece of software for GNON. It still interacts with the internet the same way, being able to communicate with other GNON components of the same type, but it doesn't access the software of the GNON component that it's part of, quote unquote, via internal mechanisms. It uses external mechanisms. And so these could be web services, for instance, or a RESTful interface, or however the provider of this component wishes to do it. So those are the two different sort of mechanisms for somebody making a component of theirs GNON federation compatible. They have to implement the federation component, either internally or externally, but without that, there's no way for their component to actually participate in GNON because the federation capability won't be there. So this federation component can be reused. Ultimately, it would be implemented within the reference implementations that I've talked about, it also can be done from scratch according to the specification if that's what they wish to do. And I didn't mention this, but let me go back for a second. In the GNON Federation here, I had a slide, but I guess I must have deleted it by mistake. But there was a slide about some of the aspects of the GNON Federation, how it's implemented. And one of them is through a RESTful API. So these nodes in the GNON Federation would communicate with each other for the purposes of federating functionality via two mechanisms. The actual mechanism for discovering the different components and being able to get information about them from themselves. So in other words, for node C1, for instance, to learn about node C2 and get information from C2 about what it offers would take place, at the RESTful API level. And then once that's been done, once C1 and C2, for instance, know about each other, there might be standards-based interoperability protocols that could then be used other than RESTful API, but sort of registry standards that could be used to actually query each other and get a dump or a download of registry entries. So there's two levels of interoperability here. One is the federation level, which will be based on a RESTful API, and one is at the actual component level, which would be based on the known standards and protocols for those components.